are probably already some things you know about negative and zero exponents, but I'm going to review the basics before we get into the more complicated things, okay, because we always kind of build up to these skills. And this will be getting harder also. This is the first lesson in the chapter, so it's a lot of introduction in this lesson. All right, so if we had 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power, what we're going to do is we're going to look for some patterns. 2 to the 1st power, 2 to the 0 power, 2 to the negative 1 power, 2 to the negative 2 power. So a lot of these we know how to find the answer to. We know how to simplify. Just as a review, the big number is called the, and these, the 2, would be called something. The base, very good. So again, the base, and then you have the exponent. We're close to getting in fractions. Stop. The entire thing is called a power. Okay, so the base is the big number, then you have the little number is your exponent, but both of them together make a power. So 2 to the 4th power means what? And what does that equal? Okay, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. What is 2 to the 3rd power? 8. What is 2 to the 2nd power? What is 2 to the 1st power? All right, I'm going to pause there. Because again, the point of me doing this was for us to find a pattern. I don't want to just tell you this is the rule and this is how you do it. I want to show you why this is the rule. Okay? So what is happening each time? 16 to 8, 8 to 4, 4 to 2. We're going by halves, aren't we? So we're taking it divided by 2 each time. Taking half of it. So half of 2 is 1. So 2 to the 0 power equals 1. 1 divided by 2 is 0.5. But I'm going to write these as fractions, okay, because that's going to help us with today. It's true that you can write 1/2 as 0.5, but I'm going to write it as 1/2. What is half of a half? Very good. Half of a half is 1/4. So what's happening here is, instead of having these whole numbers are kind of going down to the denominator. See, 2. So the next one would be 1/8. And then the next one down would be 1/16. Do you see how that's happening? Okay. All right, let me go ahead and write down the rules then. So these are properties. Anytime you have rules in math, they're called properties. So let's talk about the rule if you have 0 as an exponent. What do you think that rule would say? It equals 1, okay? So for every non-zero base, so the base cannot be 0, for every non-zero base, it equals 1. So no matter what the base is, as long as the base is not a 0, if the exponent is a 0, then it equals 1. Examples for this. If we have 4 to the 0 power, it equals 1. If we have a negative 3 to the 0 power. Now it's important that that negative sign is included in the parentheses. If a negative 3 is to the 0 power, it equals 1. Not a negative 1 either, just 1. If we have a decimal to the 0 power, 5.14, it equals 1. So no matter what the base is, as long as the base is not a 0, if the exponent is 0, then the answer is 1. Now if the base is a 0, 0 to the 0 power, that is undefined. Slope Dude would say some other words depending on what video you would watch. Okay, the next thing that we're going to talk about is what happens if you have a negative exponent. So we kind of saw a pattern there on the last slide with when that 2 had a negative exponent. So we're going to actually give it a rule now, okay? So negative exponents. Negative exponents. Again, we're talking only about when the base is not a 0. So for every non-zero base, if you have a base to a negative exponent, then what you can do is you can take that power, so again, a power is the base and the exponent, you can take that power and you can move it down to the denominator, and that makes your exponent positive. So moving the power to the denominator, moving the power to the denominator makes the exponent positive. Moving the power to the denominator makes the exponent positive. So the base would not change at all. It would only be the exponent changing from being negative to positive. And it works the other way around as well. If we were given in fraction form and the power is in the bottom, if we didn't want to write it as a fraction, then we could move the base up, and then the power becomes, or the exponent becomes a negative. Okay? You should have hopefully learned this maybe in pre-algebra last year. Okay. That's all right. So let's show some examples of that. If we had 7 to the negative 3rd power, and I wanted to write this simplified. If you write it simplified, that means you don't have a negative exponent. I can make this into a fraction, and I'm going to move my whole power down to the denominator, and that 3 becomes a positive. Because I'm making it into the denominator. Technically, right now, this is a fraction, right? It's over 1. So if I'm moving it from the numerator position to the denominator position, then that's what it's going to look like. Okay? You're kind of flipping it like a reciprocal. And when you do that, the exponent changes powers, or changes positive, negative. I don't want to say powers because I don't want to confuse you. If we had negative 5 to the negative 2nd power, our base is not going to change. Our base is what? Our base is negative 5. Okay, it includes that negative sign. Our base is negative 5. So we don't want our base to change. We want our base to still be negative 5, but our exponent is going to change from being a negative 2 to a positive 2. Okay, and that negative 5 can stay in parentheses. That's important. So let's say I have 9 to the negative 2nd power. And I wanted to write this so that I didn't have a negative exponent. What would I write? Skylar. Good. Now I could even do more with this. Some of you said, well, you want to continue, you said you want to simplify, you want to get rid of the exponent. What is 9 to the 2nd power? Yep, so you could even write that. 1 over 81. I'll look at your assignment in just a second, and we'll discuss what you need to do. We'll kind of get started on it together. How about 4 to the negative third power? Write it with positive. Sam? Okay. And then if we did 4 times 4, that's 16. What's 16 times 4? 64. So we could do that. Easy, right? Let's do one that's a little bit harder. Let's make sure that we all understand negative 4 to the negative second power. Emma? Good. 1 over negative 4 squared. And we just went through that why those parentheses were important to keep. It means a different thing when you don't have the parentheses. So if they give you parentheses, keep the parentheses. I'll say that again. If they give you parentheses, keep the parentheses. Don't decide to take them away. All right? All that okay? All right. Let's get into a little bit more complicated then. Instead of just having one base and one exponent, we're going to have more. For instance, and I actually like these better. You really have 3 different things right now. You have a 5. You have an a to the third power. And you have a b to the negative second power. So I want you to think of them individually. Okay? Is the 5 okay? Would the 5 have a positive exponent? Yes. So if it is okay, then we're going to leave it when we're writing our fraction. We're going to leave it on top. Okay? Because technically right now, it is already on top. We're just going to leave it. Is A okay? It has a positive exponent, right? So A is okay. So A to the third power can stay there. Is B okay? No. So we're going to move B downstairs, and it's going to become B to the positive second power. Yes. And then that would be your answer. And again, I like these better, because it's like, oh, you're actually doing something now. What if you had 4c to the negative third power b? I'm going to let you think about it to yourself. What would go on top and then what would go on bottom in your fraction? Tate. Awesome. So your 4 is fine. Your c needs to be moved down to the bottom because it has a negative exponent. And your b is fine, so it can stay on top as well. Any questions about that? No? Okay. We were saying that it can work the other way around as well. So if I were to give you 2 over a to the negative third power, is my 2 okay? Yes, 2's okay. Now, if I move this power with the a, if I move it up, it's going to change the negative 3 to be positive 3. So anytime you move it from either the top to the bottom or the bottom to the top, it changes it from being positive to negative, negative to positive. Okay, so if I move it up with my 2, now it becomes a positive 3. What's technically on the bottom now? Technically on the bottom is a 1, but we don't ever show that. We would just write it as 2a to the third power. It is backwards of what we did. But it's the same basic rule. You're moving it, whenever you move it from one of the positions, then it changes it from being plus to minus. Or minus to plus, whichever one it may be. What if we had n to the negative 5th on top, and we had m to the 2nd on bottom? What needs to be moved? The n to the negative 5th needs to be moved down, right? What's going to be on top? I should move m over 2 to the top? Now we don't want to move m over 2 to the top. If we move it to the top, it's going to become a negative 2. Remember, whenever you move it either upstairs or downstairs, right now it's downstairs and it's positive. We want to leave it downstairs. But this one is negative, so we need to move this one downstairs. And I don't care what order you put these in. Usually they're in order alphabetically, but it doesn't really matter. But what's going to be on top? A 1. Make sense? Okay. A little bit more to do then. For these next ones, we're going to evaluate. And whenever it says to evaluate and you're doing algebra, basically what you're doing is you're going to be replacing or substituting in for the variable and solving. Okay? So if we have the expression 3s to the third power t to the negative second power, and they are saying that s equals 2 and t equals negative 3. Before we substitute in the 2 and the negative 3 for s and t, I want us to write this so that we don't have any negative exponents. So someone tell me what this is going to look like without any negative exponents. Emily? Good. So that's what it's going to look like without any negative exponents. And now that I've done that, I'm going to go back through and I'm going to substitute. Instead of s to the third power, it's going to be 2 to the third power. So 3 times 2 to the third power. And all that is going to be over negative 3 to the second power. And again, we're going to use those parentheses. Yes. So make it into positive first, and then substitute. And last would be to actually work this out. So 2 to the third power is 8. 2 times 2 times 2. So 3 times 8 would give you 24. And on bottom, this means negative 3 times negative 3, 9. Negative 3 times negative 3 is 9. So our final answer is 24 over 9. Could you simplify that? It's okay. Mixed numbers are okay on this. Are you thinking? So I would probably divide them both by 3 first to get 8 over 3, and then that'd be 2 2/3. You could do it the other way around. You could make it into a mixed number first and then reduce. Yeah, you should reduce. You should always simplify. Let me do one more that we haven't really talked about. Like we talked about when it's to the 0 power, but we didn't work any out where we were simplifying when we had a 0 power. Let me do that, and then I think we should look at your worksheet, and you'll be good to go. If you had this that you wanted to simplify, and we're not talking about substituting in for the n and the w, okay? You just wanted to simplify it so you didn't have any negative exponents. What could we do here? So first of all, let's focus on the n. Where's that going to go? Down low. Going to go downstairs. So it's going to become n to the positive 4th power. What's going to happen with my w to the 0 power? It's going to turn into a 1. So I don't want to see a w anywhere over here in your answer. W is like gone. Okay? So the n to the negative 4th became n to the positive 4th downstairs, and the w to the 0 just became a 1. Not w to the 1, just 1. Is that okay? All right. I'm going to pause the video. I'm going to pass out your assignment. We'll look at it. Maybe we could start a couple together, and then you'll have the rest of the time to work. Paused. All right, so there was some questions about, what, number 2? So in number 2, the first thing that you would want to do is you would want to write it so that you have 1 over 5 to the 3rd power, and then you'd want to actually tell me what that is. Now, if you have an exponent, you can't tell me what it, you can't work that out. But if you only have, if your base is a number, you can actually work it out. So 5 times 5 is 25, and 25 times 5 is 125. Yeah, so your 3 would stay up top, and then your 3 to the negative fourth would become 3 to the positive fourth. And then, yes, tell me what that is. Tell me what that is. Okay? All right, go ahead. You can work together. You can listen to music. You can come ask me questions. Go for it.